Welcome to this episode of Let's Be Civil. Today's guest on Let's Be Civil is Pat Meagher. Pat Meagher has over 30 years of senior technology executive experience. He has held positions with global R&D, technology, product development, and business transformation organizations. He has worked in market sectors such as the Internet of Things, aerospace, defense, data, telecommunications, green energy, consumer electronics, automotive, and the construction industry. So welcome everybody to another episode of Let's Be Civil. If anybody watches these back to back, they're going to probably tell that I'm looking exactly the same because this is literally two back-to-back calls, and actually very different. I mentioned Pat in an intro. And I'm going to be doing another new intro for this next group of interviews, which you're a part of. But I commented, hey, we'll interview some non-civil engineers. Hopefully we'll sneak some in. Well, the interview I just did is with a HR person from the UK, and now and we won't divulge everything. You can comment on this a little bit yourself. But this is another non-civil engineer conversation, and actually another one that will probably and most likely be two conversations. So the same thing with the person I just spoke with, and I'll make people who watch yours go see theirs, and people who saw theirs come see yours. There's so much interesting content here that it's 30 minutes won't do it for us. So we're for sure are going to have a second conversation. So with me today, Pat is in Dallas, and I've got to hit my little reminder here so that I keep track of time. But Pat's in Dallas, and Pat got to know Pat with a few other people from our university. Took a trip up there. September maybe last year or something like that.
Yeah,
does that sound about right?
Early fall last year.
Early fall. Walked into his office, and we sit down, and he's sitting in this funky office. This is the millennial office. I sat down. I'm going to tell you. I'm going. This is the millennial office, the stone work or whatever. So no traditional wall covering stuff, and the big huge desks and wide open spaces and everything, and we sit down, and Pat, we just kind of start talking, and we're telling him about what we're doing at the university, and Pat and I have had this conversation, is that I could see him climbing out of his skin, getting excited, and when the conversation was done, I think he was going to explode, because we were basically telling each other, he was hearing from us more or less what you were going to tell us. And I'm hoping, we'll talk about that a bit here today. And I think, more in the second parter. But without further ado, why don't you tell us a little bit about you, Pat, and then we can get into what I'm alluding to in all of this. I don't want to give all of the good stuff away right away. So.
Sounds good. Well, thank you, John. I appreciate the kind introduction, and excited to talk to you like usual. So for the audience, just a little bit of background. John describes me as a non-civil engineer, which is true. I've never been in the AEC industry before, but I am a longtime product development executive. I've started my career in telecommunications. A lot of foundation technologies around TDMA and CDMA, and what today is the current cellular networks. A lot of satellite communications, pioneering some of the TDMA work with even NASA. And then after that, I moved into a long stint with Flextronics, a global EMS provider, one of the biggest in the world, and worked there during a very heady time. We as a team took the company from, I think, around 10 billion a year when I joined to over 32 billion when I finally became the CTO of that company. Long and really, really excellent part of my career. And then after that, sort of followed the executive team at Flextronics that had moved into private equity and venture capital, and was interested in extending, technology and products through a much larger portfolio. Still plenty of opportunity in those spaces, and still work with those guys today, and followed them to a company called Katerra, which is a construction technology startup, really trying to change the entire way that you look at buildings today. And this is where I met John and others from Texas State, that we had a great discussion. Again, as he said, I'm not from the building space, but I see this industry as a current convergence point for lots of technologies, and a great opportunity. If you look at lots of other markets, consumer, industrial, automotive, aviation, they're pretty fully embodied with current technology, in terms of leveraging and using that. And in fact, rely on that to create their GDP growth year over year. When I started looking at construction, it's like, wow, it has negative GDP for like the last 25 years and almost has no embracing of technology in there. It's like, how can that possibly work, right? And maybe that's an opportunity by leveraging that to really create, efficiencies and improvements, and, bring it into the 21st century, so to speak. And, as John had said, the common point is when we met, we were at Katerra, we're looking at lots of universities to partner with to, help maybe guide the curriculum, towards the technology outcome, maybe help by hiring, key students into the industry, and really sorting to help, form the future that way. And in meeting with John, we just struck it off right away with a very strong common view of this idea of converged technology. And also, I have to say, I was very impressed by Texas State's initiatives and willingness to do that. Kind of put their money where their mouth is through lots of different initiatives that I'm sure John has shared or will continue to share as part of his podcast. So it was a great first meeting, and we've kind of been friends and associates ever since. And I'm going to continue, working and helping in whatever capacity I can, because I think this is truly one of the biggest opportunities in an industry that I've seen. And again, just for background, I've worked in consumer electronics, I've worked in industrial, equipment, automation, telecommunications, obviously, just about every, green technology, solar that you can imagine, so on and so on. So like I say, I think this is an emerging opportunity, not only for the industry, but for all the folks that are involved and will be involved in the next, 10 or 15 years. Well, so thanks, John. Great to be here.
No, thank you. And all of that's great, because it's really, where our thought process was with the program was that, the graduating civil engineer and people that work with them, this is a skill set, a knowledge base that they're going to need to have in not too distant future. Right. And what we could do to start educating students to be ready for those kind of careers, and having those sorts of questions come up on their desk. And so when we met you, I mean, that just was a big piece, because it really did make this connection from sort of the electronics, and if you want to think of the sensor side of things, right. Into the stuff that we were talking about. So as much as you were climbing out of your skin when you started telling us about Katerra and what you guys were doing, we started climbing out of our skin. And I know that when we walked away at the end of that first meeting, we were all going, geez, this is unbelievable. Who would have ever thought that we'd come across somebody that was on the other side of things and could help us, bring this thing together and move forward. So it was really great to have met you, great to still have the connection with you. And you have since left Katerra and moved into a consulting position, but at Katerra, you were chief technology officer, or you may want to, if it was a little slightly different title. But maybe talk about what that means and what kind of things you did in a day.
Sure.
And maybe if there's a way that you can tie them into what we see as sort of civil engineering of the future, because if I'm a graduate, maybe say in 5 years or so, I might be working with somebody like you. And so, the more I understand about what you do, the better for me, right?
Yeah, for sure. First, I wasn't CTO. My boss was the CTO.
Okay.
I was the VP of Technology and Product Development, but I did report directly to the CTO of Katerra. Also a longtime friend, mentor, and just an amazing, thought human being. It was a pleasure to work with. But, and also I have moved on. So I'm now a consultant with CMG in Austin. And CMG, I think the opportunity is even bigger than, a Katerra vision, which is part of the reason why I'm so happy and excited to move on. CMG kind of works at the intersection of all the technologies, including utilities and energy, water and things like that are all really very fundamentally important to our existence as humans in the future. So I think the opportunity there is even bigger. I'm very excited to join that team and work, continue to work in this capacity. But, what I can share with you guys is kind of a day in the life thing of, what we were doing and thinking about. And I think there's like plenty more of this to come. I think Katerra and what they're doing is really the seed of this. It's not, even a partially grown sapling yet. It's a seed, and I think we need to plant more seeds, and I think it will result in big trees that could, will influence our lives for the next generations, right? So, what we were trying to do is look at buildings from a product perspective. Today, most of the buildings are bespoke, one-offs. You go on the job site, everything happens on the job site. You do a rough, blueprint of the building. It's, kind of supposed to look like this and be here, and everybody figures everything out on site, which is fine. It certainly works in the environment where you kind of do one building at a time. What we were thinking about, well, what if you had to do 100 buildings at a time? Or if you really wanted to scale this to solve, the problems of the world, like, is there enough housing? No, there's huge gaps. Is housing affordable today? Absolutely not. The data bears out that there's a big gap between even what's being built price-wise and capacity-wise, right? So we've got to figure ways to fill those gaps. So again, back to the earlier idea that the industry has not really embodied, modern technology much today. We started thinking about, well, what technologies could you bring that would help you sort of automate the process? And it starts all the way from basic software and design tools and end-to-end processes. Again, if you look at automotive or aviation or anything, even simple consumer electronics like cell phones, the products are fully digitally designed in 3D CAD day one, with complete bills of material, complete definition of supply chain, all the sort of testing and hooks and compliance elements that you need are in the digital model. And then you move into manufacturing or production, right? So we started to say, well, geez, what if you did that? What if you built buildings in a factory? What if you could really truly productize pieces of a building, design them in such a way that you have, full digital 3D CAD models where a factory could build the pieces and ship the pieces on site. And what happens on site is merely an assembly process as opposed to a construction process. And does that in fact create, value? Does it drive time? Does it drive, economic benefit? Does it drive everything? And I firmly believe it does. Again, I think we're in the embryonic stages of that, and there's lots of work left to be done. But you can fully envision things like bathrooms or kitchens or utility walls or even foundations or modular floors, build them in a factory, which what that does is gives you this idea of repeatability and scalability, which doesn't exist today. Again, as a builder, if you go and say, hey, I'm going to build one multifamily project in Austin, it's 10 buildings and, a couple hundred different things. I just sort of build it on site. But what if I had 10 or 15 of those projects going on at a time, and needed to get economic benefit out of that. Well, I don't want to have to reinvent the bathroom and the kitchen and the walls every time on every job site and start over, and it's a new team and it's this and that. If I have a fully imagined digital model in a factory, I could build, hundreds of bathrooms or hundreds of kitchens or hundreds of walls, and I can stock them almost like, an Amazon warehouse, where I can say, hey, I've got, walls that are replicable. I stock them I build them, as my factory capacity and time allows, not necessarily tied to a job and the timing of that and weather and all the variations that you get. But I can say, hey, I'm ready. I need 100 wall panels on job site A, and they pull them off the shelf, stick them on a truck, and take them to job site A. And they drop in the same way. They affix to each other the same way. You hook up the MEP the same way, right? And the crews that do that start to actually gain efficiency. So one of the things I heard, again, as a non-building guy, I really start from scratch, go on site, talk to the guys building. Hey, what are you doing? Why do you do it this way? What's, blah, blah, blah. And you learn a lot of things. And I learned one thing that, on job sites, crew A does things the way crew A does it. Crew B does things the way crew B does it. Crew C does things the way crew C does it. Some are good, some are bad, some are ugly, right? And it's like, wow, that seems like there's a lot of efficiency that could be fixed out of the system. And then if you start to think about things that way, then you start to say, well, how can I apply technology? How can I apply, data management, IoT and sensors, robots and drones and automation, factory automation and communications technologies? Wow, it's like there's all kinds of opportunities to do that can drive, potentially incremental benefit as you do, one or the other, but really like, major benefit as you start to aggregate some of those. So we undertake a number of what we call technology initiatives to go, blaze the trails there and figure out what it does. And as I said, we had a number of things that are still underway. Really IoT is like, how can you use IoT technologies to help automate a factory, to track materials, and then move that into the job site to actually control the assembly sequences of things, and then even post-building, how to monitor and create benefit at the building itself. So think of things like, as you use these new assembly techniques, maybe structural integrity becomes much more important and something you want to monitor over time. Well, you can put sensors in, you can collect data, you can monitor, and you can watch seismic events and see if buildings wear and tear the same way that they do now, and create data that affirms those things and manage the data. Wow, that's really cool. So doing some of that, same thing like, water detection, floods are really tragic when it comes to buildings, and even mistakes like overflowing tubs. You can monitor and control those things. Things that are important to the inhabitants, things like security and proximity, access, air and gas, water quality, maintenance cycles on HVAC systems and, other, products that are routine in a building environment, all have tremendous promise and economic benefit and value as we start to embody those. And my hope, maybe it's a bit of a grandiose hope, because we've certainly got a lot of work to do to change the industry a little bit, is that can actually reverse the GDP trends of the last 20 years. And let's get that, inverted V to be like an upward pointing arrow, like the rest of the industries in the world that make routine use of this. So to me, that's just a tremendous opportunity that's ahead of us. And actually, maybe in the sleepy industry domain of AEC, that's a very exciting development and a very good prospect for the future. So that's kind of why I'm here and working on that. And, again, I think you look around and you say, wow, a lot of the other industries in the world have fully embodied that. And there's certainly opportunity there, but it's not nearly as much like the Wild West as it will be, for this industry. So
real quick, a couple explanations. So AEC means what?
Architectural, engineering, and construction.
Okay. And then you said MEP.
MEP is mechanical, electric, and plumbing.
Okay.
So think of those as like the guts, if you will, of a system of buildings, right? And maybe to extend on that, one other really cool thing is, what I've been able to do is take my experience in telecom. If you think about telecom today, it's very modularly designed and broken up against standards. that allow you to create, rack increments and, backplane interfaces that define, power, ground, communication, control signals and stuff. And it's all grid based, right? So it's very scalable, very repeatable, widely used, widely accepted, widely understood, and still allows a big envelope of innovation to happen. Well, I think we need to do the same thing in buildings, is make them grid based, modularly designed, define things like all the MEP. Where does plumbing go? Where does energy go? Where does, command, control, security go? And start to build out that way, and then innovate inside of those envelopes. And I think, again, that's a huge opportunity in the way that we, myself and others, are starting to think about, what a building looks like, again, as product guys, not building guys. And again, even doing that, you still run into the head square realities with the building guys of, you can't do this, you can't do that. But, we routinely fight and argue about that, which is like, refreshing and opportunistic for me. So.
Would it be fair to say, both at Katerra and at CMG, that a lot of what you do is thinking about innovation? The way that you're going to accomplish the things that you're mentioning, somebody has to sit there and sort of contemplate, how could we do this? Is there some other example of a technology that we could slide over into the construction arena? You as sort of a leader, both in Katerra and now, as a consultant, people are looking to you as a leader, a knowledge, a person with an extensive knowledge. Would you say that that's a good chunk of what you do? Is you have to think, think tank kind of. You're an individual think tank in a way?
Well, let's see. So there is certainly some of that, but I'd like to direct your audience to the idea that what we do and what I do is for sure that to start with, but in today's age, to very quickly cut to the practical realities of implementation, right? So if you say, let me just use an example. Hey, I think I can kit a component of a building and build it in a factory and deliver cost and time benefit. So if that's the thesis, the work is like, well, let's go get busy and do it. What does a wall look like? How do you connect it? How do you build MEP inside of it? Let's get in a lab and build some of these things and load them up on a truck and go, oh man, by the time I shipped it from the factory to the job site, half the plumbing fell out. It didn't work. Oh, you got to work on that, model. So I think the reality is that in the building world, it's more practically based in that you have to very quickly go execute and embody the concepts that you come up with in reality, build a prototype, test and evaluate it, gather data, move it onto a job site, let normal, job site trades do the work and give you feedback and go, you know what, Pat, that was the dumbest idea I ever heard of. You can't do things this way. You go, okay, thank you very much. Right. I appreciate that input. We'll go back and think about it some more. Or more routinely, what I see is they go, first off, they go, oh, this is crazy. Why would you do it this way? And blah, we don't do it, blah, 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 blah. Then after you do it 3 or 4 times, you go, well, this is amazing. This is actually much faster. And by the way, if you move this stud or this screw or that pipe here or there and made this joint work, it would be even better. We go, nice, thank you, I'll go do that. And again, what happens is we see, tremendous gains in efficiency in that, the first 5 times a job site team does that, they complain and whine, it's different, it's hard, you can't inspect it, you can't do this, you can't do that. And then they start going, well, if you change this, it would really be cool to like, wow, this is really fast and super efficient, and also sort of levels out a bit of the skill that's required in the field today. That may be perceived as a negative, but I think, one of the big gaps today is it's hard to get skilled people in the field, right? So maybe you could move some of that skill into a factory and make it a little bit more level on the job site so you can fill a bigger demand and create, better economic value. So a large part of it is think tank, but I'm a hands-on guy, right? I'm a product guy. And really at the end of the day, all the greatest ideas in the world aren't worth a plug nickel if you can't implement them and realize the value in the field. And that's a lesson my mentors and the great executives I've been fortunate enough to work with in Flextronics and ComSat and even Katerra, kind of hammer that home. It's like, love your ideas, they're a dime a dozen. Let's go actually prove it out and validate it, right? So validation of these things is very important. And then once it's validated, then you can, make case studies and start to talk to other people and say, no, look at this data. Here's what we found. Here's what we did. Here's how it worked. And it actually created, XYZ benefit. And then it gets credibility, right? Because I think that's the important part for me.
So how have you seen things, because the civil engineering world does not move very rapidly. Projects are big. They can be very involved. Like you said, people don't like to change from the way they've been doing things because there's there's a safety net there. If I do it the way I've done the last 20,
right.
And
no risk, right.
Right. And, how has it been for you trying to then say, hey, 5 minutes on an idea, let's go try it, as opposed to, I suspect a lot of what you've come across has been 95% of the time, let's think about it, and 5% of try it. You're really the reverse, right?
Yeah, I think so.
So how has that gone for you?
Yeah, I think that's actually gone well, except that I will say it takes time. If you think about, the product development life cycle, if it involves hardware, software is one thing. We've got this day and age where you bing, 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 here's your software product. Oh, you don't like it? Bing, 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 here it is.
Right.
But when you think about, hardware, phones or tablets or computers or cars or buildings or airplanes or whatever, a much, much longer development cycle in that, you're doing all the CAD design and all the engineering work and so on and so on. It's no different with buildings. So what we've done is tried to incrementally attack that, as opposed to saying, hey, let's change everything day one and introduce, 50 variables that you got to go figure out. Let's introduce 2, right? Validate them and see what the effect is. So we've very much taken that approach, and I think that will continue for a while. I can share with you the reaction of builders and developers that I've interfaced with on the business development side, trying to, embody some of these technologies, and kind of, this is summarized, kind of universally, they go like, I don't know, man, that sounds risky, right? We do things this way, we don't do them that way, but you know what? It sounds interesting. And by the way, as a company, I know the industry is changing rapidly. And quite candidly, I don't actually know what to do to adopt, to the future. But, if you could incrementally give me this product, whatever it is. And when I say product, it's not like here's a faucet or here's a toilet or here's a pipe. It's a integrated set of subassemblies that are built in a factory that drop into a building. They go, you know what? I'm willing to try that because that looks interesting. And I could see building a building out of integrated subassembly components versus raw materials could be a way to speed the cycle time. And if it does that, I'm all in, man. Right. So they tend to say, here's a project, right? And if this project works good, I got 21 over here that I'm going to give you, but you better prove it here. So we're still very much in the sort of the proving state, if you will. Very necessary step. People are prudent, cautious. They've been doing things this way for 20s of years, and it works, and there's not much risk. And nobody likes change, right? That's just a human thing.
Right.
And so you have to sort of incrementally approach that, and that's the way we're trying to do it, right? That's why I say it's kind of a long-term thing, but I think it's a very exciting opportunity. And I find that a lot of, again, the folks that I've talked to that are maybe builders or developers, they're very willing to take that first step and validate the whole concept, right? Hey, can you just give me this piece, right? And let me try and see how it works, and let me get my guys familiar with it, and so on and so on. And if that's good, we'll go do other stuff.
Right.
And there is a lot of precedent for that in my previous industries too. So I see some repeatability of that, and I can share some stories whenever it's appropriate about some of the things that actually worked that way that led to exponential growth in other companies.
Yeah. So I'm going to blow you away. I mean, we're past 25 minutes of talking, and it's just like that, right?
Oh my gosh, we haven't even scratched the surface.
Right.
Yet.
This is right. This is our conversations, right? I mean, So
right,
this is why we're going to have a separate conversation and talk about this idea of the modular construction, and maybe really kind of walk through it from first steps, and if we can pull up some images to show some people and stuff like that, I think
certainly
will be good. And that probably will go way too fast, and we might have to have a series. We'll just have a series of conversations. But to wrap up this particular conversation, tell us a little bit about the stuff you do outside of work. Work is extremely exciting for you. I can tell. I mean, I've known that from when we first met, that you really enjoy what you do. But what do you like to do when you're away from the office?
It's funny. You'll probably laugh because I consider myself to be probably one of the most uninteresting people you'll ever meet. What I like to do when I'm home is like turn the lights off, lock the door, turn the phone off, and kind of like hide, and not do anything so I could decompress a little bit. And and I have a small bit of land out in the country. I go out there and I mow grass. Get on my tractor. I love mechanical things. Get on a tractor, mow grass, and it actually allows me to decompress a little bit and think. Again, a lot of my thoughts and maybe ideas and benefits don't come from like sitting here and staring at a piece of paper or tapping keys. It's like I'm out, mowing the grass. I go, oh, what if you took this piece and did it that way and linked it? Let me go. Great. Now I'll finish the grass. I'll go in and work on it. So that sort of downtime gives me the ability to like be even more creative or more adventurous, if you will, in the ideas and the concepts. So, outside of that, not too much. I have, lots of funny stories about, maybe the intersection of technology and life experiences and raising kids and stuff that are maybe funny and interesting. But, outside of that, probably not a whole lot that would engage your audience,
Well, but it's still an interesting comment because I'm going to very, very much relate to it. I do more productive thinking doing landscaping work around my house than I do sitting in my office, because you're doing the work you need to do for the day. Sometimes it gets overwhelming.
Yeah, it gets monotonous and overwhelming.
Right? And you get another call and there's another email and another text and all that sort of stuff. And it just, I think you said it very well, that you go on a hideaway to decompress and let your mind settle. And actually it's when your mind settles that it can be highly productive. That's what I have found, is that when I'm doing something else and I'm relaxing, in doing that other thing, and I'm not thinking about work, is when things that help me move forward in work come to the front of the brain, and you start you contemplating, then I got to stop myself, because then I'm right back in the work environment.
Many times I've stopped the tractor, got off the tractor, come in the office and scribbled something down, right? So I don't lose track of it, and then go back out and finish what I'm doing, right? So I can build on it later. So very much my methodology as well.
Yep. Maybe we were separated at birth and we just are finding out about it now, right?
Brothers from another mother, I think, right?
Yep. If you're a 70s music fan, you know where that came from. Do you?
Let's see.
You know the album?
Well, I don't, but I'm not sure you can hear it. But in the background, I have on the Grateful Dead. So for me, it's Grateful Dead Fridays is a thing I've done for my whole life, coming from a place where I used to think that was like hippie freak music to now it's like the most endearing, musically rich music I can find. So Friday I set aside as Grateful Dead Friday.
Hey, thanks for spending some time with me today. We will have a follow-up, and I'm going to encourage people to look for that.
John, thank you so much. Always a pleasure to talk with you, and hope your audience finds this interesting. And I agree, there's many other tracks we could follow to help expand on this, and happy to be part of that as you need. So just keep in touch. Okay.
Appreciate it, sir. Have a good day. I'll talk to you soon.
Good day. Bye-bye.
Bye-bye.